All right, let's take a look at number one. So when you see number one, I kind of want you thinking about bases, powers, and results, as we've talked about before, broken record bishop. So for number one, I see a base, I see a power, and I see a result. And the 40 is neither a base nor a power nor a result. So for that reason, the very first thing we're going to do is get rid of that. So we're going to divide both sides by 40 because the 40 is currently getting multiplied, which leaves us with just 3.5 to the power of x plus 2. And 10/40ths, if you divide that, is 2.5. Okay, at this stage, you should notice we have a base, we have an exponent, and we have a result. And we're trying to solve, obviously, for x, which is an exponent. So this is when you can apply the inverse of an exponential, which is a logarithm. So I'm officially going to write log. So I have log, and then the base of the exponent becomes the base of the log. So that's 3.5. The result you're trying to achieve goes in parentheses. So that's 2.5. And the exponent goes now on the outside. The input of x is now on the outside because indeed they are inverses. Now, if you just type all of this into Desmos, it's just a number. Log base 3.5 of 2.5. Type that in Desmos, you'll get an answer. It's 0.731. 731. So that's the answer that you get when you type this into Desmos. And then as far as the equation is concerned, it is still equal to x plus 2, which is why the very last step on this one is to subtract 2. And if you subtract 2, you will get x equals negative 1.269. 269. And that is the answer for number one. Now you'll notice on number two, it's already a logarithm. And so you can already see an log. So that's how I know I'm in log form, is because log is there. So I'm already in log form. So in log form, I can see that the base is 7, the result is x, and the exponent out here is negative 2. But then, what about the dividing, or what about the timesing by 2 out here, and what about the subtraction of 6? Those are neither bases nor powers nor results. So that's how I know that those need to go first. So I'm just going to use regular inverse operations. I'm going to add 6 to both sides, which leaves me with 2 log base 7 of x. Negative 2 plus 6 is 4. Once again, divide by 2. It's neither a base nor a power nor a result, which now leaves me with log base 7 of x. 4 divided by 2 is 2. And then at this stage, you should feel somewhat stuck, but that's because that means you're ready. So this is the basic log form of bases, powers, and results. The base is 7, the power is 2, and the result is x. That's all that's left. So that tells me I'm ready to write it in the inverted exponential form. So we just said the base was 7, the exponent was 2, and the result is x. Well, 7 squared is 49. So the answer is x equals 49. Done. Number three is in exponential form. There's no log written on the page, so I know that I'm in exponential form right now. So the base is 7, the exponent is 2x, and the result is 80. And there's nothing else there. Everything is accounted for. So that means you can go immediately into log form, where the base is 7, the result we're trying to achieve is 80, and the exponent is 2x. Log base 7 of 80, that's just a number. What power of 7 makes 80? Well, I don't know off the top of my head, but it's probably 2 point something. If I put that in Desmos, I will get the exact answer of 2.25 is now equal to 2x. So one more quick step of algebra, and the final answer here is 1.126 equals x. So that is question 3. Okay, moving on to number 4. So number 4, we can tell, is in logarithm form. It happens to be a natural log. Remember, that's just log base e. So I'm currently in log form. And so the base is e, the exponent is 1, the result is x minus 3. So the plus 5 is none of the above. It's neither a base nor a power nor a result. So that tells me the first thing I need to do is use inverse operation to get rid of that plus 5, which leaves me with the natural log of x minus 3 is now equal to -4. Okay, well, this again is where you should be feeling almost stuck because you've gotten rid of the plus 5 and now you're just staring at a log statement and you're like, what the heck does this even mean? Well, excuse me, again, you're in log form. I know it says natural log, but that's just log base e. So when you look at this statement, you've got base e, exponent -4, result is x minus 3. Everything is there, everything is accounted for. So let's just write it in exponential form using those bases, powers, and results. So the base was e, the exponent is -4, and the desired result is x minus 3. Okay, so e to the -4, I know that looks weird, but remember e is just a number. So you can compute that. If you just go into Desmos and type e to the -4, you'll get that value, 0.0183. So I'm just going to write 0.0183 is equal to x minus 3. One last step to solve for x, and that is how we get our final answer of 3.183 equals x. Okay, there's number 4. Moving right along to number 5. Okay, number 5 is clearly in exponential form. You can see there's an exponent right there. So it's exponential form. It does not say log. It does not say ln. It is not in log form. It's in exponential form. So in exponential form, we have base e, power of x, result 29. Notice the 5 and the plus 4 are not accounted for. So that's why the very first thing we're going to do is get rid of those just because we can. They're neither bases nor powers nor results, so get rid of them. So start by subtracting 4. You'll have 5 e to the x now equals 25. The 5 is getting multiplied, so divide both sides by 5. And now it says e to the x is 5. Okay, now again, you're looking at that and you're like, I don't know what to do. I'm stuck. Well, that's because you've exhausted all the other algebraic approaches, and all that's left is a base, a power, and a result. So since you're in exponential form of a base, power, and result, that means it's ready to get written as a logarithm. Now, this is the one where technically you could say that what you're working with is a log base e of 5 to get x. That is technically correct. If somebody who knows any math would walk into the room, though, they would look at that and they would say, log base e, don't you just mean ln? So then we could, if we wanted to, the natural log of 5 equals x. And these do come out to be the same. So if I do log base e of 5, I get 1.609. Or if I just take the ln, natural log of 5, I also get 1.609. They are equivalent. Certainly, the more sophisticated, if you will, option would be to use natural log. Anytime you're working with base E, that's when natural log is most appropriate. But they do technically both work. So we now know, thanks to Desmos, the final answer here is 1.609. Okay, last but not least for this section. Okay, what we're starting with here is a log statement. It says ln, so yes, it's a natural log, but either way, it's a log statement. So when you're looking at this, natural log is base e, the exponent is 12, the result is 3x. Notice the 7 is unaccounted for. It's neither a base nor a power nor a result. So the first thing we'll do is get rid of that. So divide both sides by 7. So now we have the natural log of 3x is 12/7. You can get that decimal if you want to. I'm just going to leave it as a fraction. And so now if you're feeling sort of stuck, it's because you've done the one inverse operation that you feel comfortable with, and all that's left is a base, a power, and a result. So you're ready to take this out of logarithm form and write it into inverse or exponential form. So what did we just say? We said that the base was e, the exponent is 12/7, and the desired result is 3x. Once again, e to the 12/7. I know that feels weird, but that's just a number. So e to the 12/7, e to the 12/7 is 5.55. If I round it, we'll say 5.55. So thank you, Desmos. 5.55 equals 3x. One last step, divide by 3, and put that in Desmos. You will get 1.851. And that wraps up that top section. Okay, I'm going to make a separate video for the next ones just so that we can kind of have everything in like categories, if you will. So we're going to call that one a wrap. We'll come back for number 7. Thank you.